So, pretty much 101 on the machine shop. Closed-toed shoes, a must, period. Safety glasses, a must, period. I don't care if you're going in for 2 seconds or 2 hours. Wear your safety glasses. I don't care if you're not cutting anything. I don't care if nothing's being done, if you're just standing there. Wear safety glasses. Because somebody else can come behind you when you're not paying attention, turn on a machine, a piece of aluminum can go flying through the air and hit you. Okay? Alright. So I'm pretty much going to take y'all into the shop, show you each tool, show you how you should clamp each piece of material to the tool, because clamping is actually the most important thing on everything. And after we do that, you'll then do it yourself. Once you do it yourself, you're good to go. And before I forget, if you're a girl or if you have long hair, tie your hair back. We've had it where a girl has actually caught her hair in a drill press. We almost cut her hair off. So we have different machines here, from belt sanders, scroll saws, table saw, band saw, horizontal band saw, compound miter saw, and our standing drill press. Hopefully in the future we might get a lathe, mill, or CNC. We'll see. Then we also have power drills. They're outside somewhere floating. So I guess we can start with this guy right here. This is our band saw. Pretty much, it's what y'all have been used to. It's a blade that rotates on 2 wheels. Don't really ever stick your fingers in here. It's not a great idea if the thing's on, even if it's off, because they can just switch on. I've seen machines just switch on because bad electronics. You're normally just going to cut mostly your aluminum tubings, shafts, sheets of Lexan, just small things you need to cut. So say you need to cut, I shouldn't pull that. Oh, here we go. This guy in half. What do you think is going to be better? This guy, the horizontal bandsaw, or the compound miter saw?
This guy.
Or the bandsaw, the regular bandsaw. Because this way you can try to keep your fingers as far away from the blade you can and go down the line. On the chop saw, I'll show you later, something this small is not a great idea. Same thing with the horizontal. It's actually the small, it's not a good idea either. Okay, so I'm going to ask y'all to come up and pretty much start trimming this guy away. So how you want to do with straight cuts is mostly, you actually want to use your guide. Put them here, do whatever measurement you want, hold it tight here, try to keep this guy away from the blade. Once your piece has gone all the way through, you can then keep holding onto this one and turn it off. Then you can go around, reach around, and retrieve. This is going to be the one machine you're never going to use a clamp on, because since you have to push it into the blade, clamping. Goal 1 with anything that's over an 1/8 of an inch thickness, go slow. If you go fast, you'll clog up the blade, it'll slow it down. Then you get that weird burning smell. You don't want the weird burning smell. So pretty much, like I said, anything that has a battery. Clearly has a battery. Doesn't work without it. This is mostly what we're going to be using probably outside the shop and during competitions. So this is probably the one tool you're going to become best friends with. So don't get in a fight with it because it will beat you up. Power drill is pretty much like a standing drill, but it's mobile. We have cordless and corded. The only main difference between the two is corded does have more power and you'll need a chuck key for it. The great thing about the cordless ones are they're adjustable for torque. So as you can see, this twist, sadly all the numbers are gone. But basically you go towards that direction, I'm just going to say that direction. It goes more torque, more torque, more torque until you get to a drill setting. Or even, you can't stop it. But if you go all the way to the other side, there's a clutch. So you can stop with your bare hand. That thing has no torque. So pretty much you want to use the torque settings when you're actually in bolts, screws, or taking out bolts and screws if you're actually using the drill, because if you don't, you'll end up completely stripping them. Who here knows what it means when you strip a screw? Pretty much you know the heads of screws, right man? Julian?
Yeah.
Like it's a Phillips flathead, hex, torque, double square, triple square. You never get anything with a double square, we can't find those. Pretty much it's when you're going at it, and then all of a sudden you hear it skip in the drill. So what's happening is you're taking that corner and you're yanking it across and you're turning it into a circle. Once it's a circle, no bit's gonna get in there. Your options are drill out, vice grips, or turn into a flathead if you have enough material left, and hope a flathead screwdriver takes it out. So don't strip screws every time through the strip screw. I wanna ask 50 cents from y'all. I'm gonna have like a strip screw jar, because that's probably the one thing we're gonna do the most. So, power drill. Be careful with these guys in the sense of when you're putting in a drill bit, you want to put it all the way down to the base and then turn it for tightening to that point. Some of y'all might not tighten it enough, and so what's going to happen is when you're drilling, it'll come loose and fly forward. Don't freak out, just turn it off, put it back in, try tighten it. You can put anything up to, I think, 1/2 inch bit in here, if I remember right. Anything bigger, I don't know if we can do anything bigger without using a drill press. This is a bandsaw, and it happens to be horizontal. It's actually one of my favorite tools to use here. It's actually one of the safer ones we have, in the sense of once the cutting starts, your hands are as far away as a blade possible, and you never have to worry about turning it off. We can lock this up to be a horizontal or vertical bandsaw. I don't trust it 100% yet because we as mentors haven't used it. So until we kind of say, green light, you're good for it, don't lock it up. Like always use it as a drop. Ooh, this one will be fun. Is you take this piece, you put it in here, you clamp it. It has its own clamp, which is beautiful. Once you clamp it on tight, you will turn the guy on, and you will literally put it about here and drop it. That's it. You're going to see that it's amazing, and it might look like a scary machine, but it won't. So, volunteers, somebody, anybody. I want to pick somebody out at random. Her hands first. Alright, so pretty much, yeah. So you can dictate how much you want to cut off by kind of test dropping it a few times. That's the only downside of this guy. Like, okay, that's about where you want it. Sure, why not? That's where you want it is. Go ahead and clamp it down as tight as you can. Okay. So you're going to turn it on. You're going to grab that handle. Take it there. Now drop it. And as you see, it's cutting away. Okay, so pretty much what this guy's supposed to do is adjust how fast it'll drop down. You're supposed to use it when you're using thicker material. Just think about it, it's like the drill press, or the drill. If y'all like pushed really hard on it, it'll stall up, right? Same concept with almost any of these tools. If you push too hard on the blade, it will stall up. So, drop it. And the reason this part's taking so long, you're on the flat. So instead of just 2 points of the teeth, it's every point on the tooth going at it, going at it, going at it. Sooner or later, it will cut. And it turns itself off. Beautiful, right? Once it's off, raise the arm, unbolt, or unclamp it, and you have your piece. It is straight-ish. We're probably, actually, that's why I wasn't straight. Because if this guy's, whatever angle this guy's going to be, that's what the entire cut's more or less going to be. It's still like a bandsaw. It's still going to waver a little when it's going down. It might go at a slight angle. But compared to that, instead of here, it's like this. So it's tolerable. The most dangerous tool in this shop. No, I'm actually not kidding. This one will take your finger off before you say ow. I'm not kidding. We've had incidents in the past with an old team, with a guy misusing this, and now he has 2 steel rods in his fingers holding it together. Do you want 2 steel rods in your fingers holding them together? Do you want to go to the hospital? Didn't think so. So use this correctly and respect it. With every other tool, respect it. You might become so comfortable with it, you're like, oh, I can do this with my eyes closed, oh, I can talk to my friends, I can text and that. Probably. But just like in your cars, if you do any of that, one mistake and you're flying through your windshield dead. Okay, so honestly, this is probably one of the more dangerous ones. It's probably the most high RPM one we have, minus the drill press when we actually put it at a high RPM. But this guy is what you're going to cut most of your stock material with. Like anything this sized or...
What's stock material?
No, stock material is raw material, like what we have here. Long, useless, okay, not useless, but it's long and awkward to move around, right? So if you take this guy, and you only need 2 feet of it, how are you going to cut it? That guy, that guy, that guy. Drill press! No. Yeah, this guy would be the best way. This will also give us the straightest cut. So, like on our lift, we wanted everything to be square. You use this to cut all the ends. This guy will give you the straightest cuts, the cleanest cuts, and it will be the quickest way to cut thicker material. But just like any other blade, go slow on it. Go too fast, you might bite weird, and the piece might actually fly out. Congrats. This is one where clamping is probably the most important thing you'll ever do in your life. Because if you don't clamp this guy right, he will fly out. So pretty much you want to use C-clamps before you put them on the floor. He used to have this little clamp attached to him, but we have yet to make a replacement disc piece right here. Normally you can cut up there, push it down, clamp, and you have one side fairly well clamped. And if it's a long enough piece on one side, you can use your hand to grasp here and cut. But since we don't have this disc anymore, kind of useless.
It's always, I think, personally, it's better to use a clamp than that disc that we had anyways, because the disc only clamps it from the top.
Yeah,
the clamp pushes it against the wall, so it has nowhere to go.
But yeah, use a C-clamp. If it's a long piece, that clamp would have done. The smaller your pieces, the actually scarier this thing will get. Because think about it, you have all this momentum with a small little piece. What's going to get first? That blade or the little weight? The little weight's going to get first and fly out. So you want to use this guy. You normally want to attach them to the base over here. You'll have like a few like, oh, I'm going to attach here, here. As long as you get them down good and flat, they'll be fine. So the meat lighter gave me the biggest C-clamp we have, because it's going to take forever to tighten this guy up now. But you got it. It's on there. That's going nowhere. Okay, that might go somewhere. So when you're cutting this guy, you also have to remember which side of the line you want to cut on, left or right. Because there is a thickness to this blade. And that thickness, when it takes contact onto the piece of metal, that thickness is going to be gone. Just dust. Like, seriously, dust. Pretty much keep it slow. What you're going to want to do is pull the trigger on this guy, start it, cut, come up above it. At that point, once you're past the material, you can let go of it, then return it to starting position. After you're done with this tool, you're going to actually want to push it all the way down and lock it in its downward shape. I would show you, but I don't want to unclamp this just yet. And it's a little safer in that position because like say you're not paying attention, you're talking to your friend like this and you just click that. Also, when we leave the shop, unplug this tool mostly. Okay, so what did he do slightly wrong?
Let go inside the piece.
Bingo.
Yeah.
The reason you don't want to do that is once you let go inside the piece, it doesn't slow down nicely. It like goes slow, slow, then it crashes slow. When it crashes slow, there's still a lot of momentum. This piece can do that. It can fly a different direction. It can do something weird. But make it a habit where you don't. You want to stop it when you're above that piece. And when you're done with this greasing machine, just push it down. There's a little knob down here that you just have to twist to make it horizontal, and it'll stay this position. And we can compare cuts. You're going to use a jigsaw with plates in sheets, like of aluminum, Lexan, plywood, drywall. So the good thing about this guy is he takes all the batteries that our drills do. And so, as you can see on it, there's different settings for steel, wood, PVC piping, chipboard, and 2x4s. You're normally always going to stay with 0, actually, because we're mostly going to be cutting sheets of aluminum. If we're ever cutting sheets of Lexan, just push it to 1. It's the same concept where if you pull the trigger, it turns on. It's kind of loud. It has a variable speed up here. So if you're all the way down to the bottom, that. If you're all the way to the top, you can on the fly adjust it, which makes things nice. If you're doing something thick, go slow, so adjust the speed. If you're doing something thin, go fast. If it's aluminum, go fast but push the blade slow. So normally how you're going to cut sheets is actually probably on the table. I don't like C-clamps. They take forever. And, okay, the thing difference. This guy's really good for this type of stuff. But for like that guy or something you want to clamp down and you're going to pray that it never moves for a day of its life, use a C-clamp. These will give out before that does. So we're going to cut a little section of this guy off. So what you're going to want to do is put him to 1, which he's already at, about whatever speed you really want, just not very slow. You're going to come to him, press down, don't try to lift up. If you try to lift up, this is going to wobble like crazy on you, and it's going to make your cut inaccurate, and it's going to make a really horrible noise. So you want to press down and push forward. Once you push forward, you're probably going to stop about midway because there's a clamp in your way. Normally, we're larger sheets, only needing maybe like 6-10 inches out of it, so you can draw out your square or your rectangle or whatever you need, and just cut around the edges. Don't put your fingers in it, please. There. So pretty much small things go on this vise, like small little insignificant little things like pieces about yay big. Big guys, like say if you're actually trying to drill through a 2x4 or a 2x1, this guy. Anything you need a substantial amount of pressure, this guy. Because this will give out on you first, especially since you have to do that. So, the drill press is going to be what you're going to use for any holes that you want to keep straight. Well, before you're actually building a robot, you're using this guy mostly. Because everything's in parts, nothing's assembled. If you want to put a hole for a bearing, use a drill press, not the other one, not the power drills. This thing can go all the way up to, with the drill bits we have, what, like 1 inch and something? But when you get anything past a quarter really, you want to go slow when you're going through it. Because you're taking out a lot of material once you're cutting through. So if the slower you go, the straighter it will be and the less ugly noise it will make. And less likely this will stall on you again. Again, if you're going to go to a big drill size, like say 9/16, don't jump straight to a 9/16. Make a small hole and gradually get bigger. If you just jump to the big one, you're never going to make a straight hole. The hole's not even going to be a circle. It's going to be like a weird shaped oval thing that's going to be almost useless. So, with this, we're going to go ahead and just use the drill bits in there. It looks like a 1/4 20 anyway. You always want to use your drill vise. Don't hold this with your hand, like don't drill and hold, because this has more torque than your little arms will ever dream about having. This you're also wanting to clamp down depending on what you're drilling. If it's a really small piece, clamp this guy down. If it's a larger piece, since there's so much weight, you can option not to clamp it. I would still say clamp it on the side of error, because you never know what's going to happen. And yeah, hair tied back if you have long hair. And what you also want to do is test to make sure your drill bit is going to go all the way through, or at least to the depth you want it to. Easiest way to do that before you actually start drilling, just get them out of the way, one or the other, and just lower the arm. And say you only want to go through one part of the 2x1, or the 1x1, that's good, right? If you want to go through all of it, it ain't going to work. So pretty much what you'll do at that point is, back here, there is a latch that squeezes this like a clamp, and then you can roll this guy up. So whatever distance you want, wherever your heart desires. And so then after that, you can test again. Y'all think that will go through? So go ahead and tighten this back part up, because what this does, also when you tighten it, it sets everything back straight. Also keeps it from, if you're drilling something really heavy, this will start popping down if that's not locked back. And trust me, that will actually partially scare the crap out of you. So Max, you can commence drilling if you feel like you have everything properly set up.
How do I hold the clamp?
Well, you gotta get a clamp.
We can clamp the clamp.
If you forget that there's a spinning wheel on that side, and you'll end up hitting it.
Okay.
So if you don't think it'll go anywhere, go ahead and turn it off. Slowly drop the arm. That's what happens when you're going a little too fast. You didn't go through it. Now you're they're pretty sharp actually, and they really suck when you get cut by them because they're almost paper cuts sometimes. And I don't think anybody likes paper cuts. So normally we'll have a deburring tool, we need to pick those up. But what you can do is get a larger size drill bit, go ahead and center it on the hole, and you can twist it. And that will mostly deburr the guy out. This side actually came out really clean, so there's almost no point. But as you see, that has no more burrs. So you can run your finger on it, you won't get cut. Also for FRC, everything needs to be filed down. If an inspector can get his finger cut on your robot, you're not passing inspection, meaning go file. Belt sanders. So pretty much a sander is to, in our case, mostly to deburr things or take off a very slight amount of material. Say something's like so small that using the bandsaw would be borderline stupid dangerous or just not a good idea. You take it to the sander and you slowly take off the material. You are not going to use a sander to take off a large amount of material. It's not a good idea. It will clog up all the belts or snap the belt like that guy. And because this is aluminum, it doesn't come off like normal material. Aluminum, when it gets hot, has a very low melting point, so it kind of clogs inside all the sandpaper. So it's only for deburring, slight material loss, not a large. So say I want to get rid of half of this. Would I use a sander? No, I just cut it out and sand the rest of the bird away. This guy has nice sharp edges. This would not fly in FRC. So somebody come and get FRC approval. Is this how y'all are in class? Like, who had the question?
My class.
So clearly that one's not going to work. Yeah, you can use a disc, but for this guy it's easier to use that. Okay. Okay guys, so with these sanders, they're Harbor Freight. They're Harbor Freight sanders. So if y'all would like to come this way. With tightening this, you want to twist this guy away from you. They'll try to tighten it. Again guys, Harbor Freight. You don't want to push this guy all the way up, as you can see. By the way guys, never hand a screwdriver tip first. Always handle first. It's like a knife or a box cutter or anything else. Anyway, make sure that it's not eating away at this guy here too, because otherwise you're going to wear out that sandpaper.
Snap that belt.
You're going to snap the belt too. We've already did it once. You're going to turn it on, and with this guy, a lot of you, what you're going to want to do is take them flat and push them forward, right? That's how most of y'all would want to do it. Normally you're going to take the edge and just run it across each side, and then with the tips, just touch it, just round it out. All you're trying to do is get rid of the burrs and round everything. You're not trying to take off material, really. So it's just a quick run each side and each tip. So, Lucas, go for it. There's no way I can actually cut myself on this guy unless I stick my finger in here. Hopefully most of the material we'll have will cap it off with like another piece of metal. Maybe we'll get fancy 3D print parts to stick in there. Or you can have the fun job and file it. I'm sorry guys, there's no electronic filer for the inside.
Dremel. Yeah, there is.
You can Dremel it, or you can learn how to use your muscles and use this guy. It's just a quick pass though. It's like done, done, done. Good enough for done. Normally they're not going to like stick their finger in there and look for every little nook and cranny of the sharpness. They're just going to run their hand through it, and if something catches their like skin a little bit, they'll tell you to file it. So if we're in inspections during actual FRC season, I'm going to expect everybody who goes up there to have a file in their back pocket. Because if he's like, oh, this is sharp, file it, ask him to check that section again. If it's good, we're good. Because the sooner we're done with inspection, the quicker we can get on the field. Alright, table saw. We're probably only going to use it for a sheet of plywood, 2x4 cutting. Alright, so this is a table saw. You can use this guy basically to adjust your guard, left or right. This will be butted up, the distance you're going to cut. More, less. This is the height. So say you only want to cut into half of it for who knows what reason, but you want to cut into half of it. You can go ahead and just cut into half of it and make a slot. You can then put a piece of aluminum in there possibly and use it for who knows what. As you adjust up and down, you'll see the blade go up and down. So, I don't feel like cutting it in half, so I'm just going to cut it partially. We also, yeah, this one does have it. You can also adjust the angle of this blade, 45 degrees, I think one direction, yes. So you can make 45 degrees cut this way, but unless it's big sheets of plywood or something like that, there's not a real reason to use this. Like any of these types of cuts, unless you're going partially into the material, you can do it on the chop saw. If you're doing a cut this way, chop saw, straight down, chop saw. Again, big sheets, this is what you're going to use. This is your extended arm pretty much. Say you have something a little smaller, you're going to use this guy to push through. Why this guy instead of your hands, guys?
You like our fingers?
Exactly. I'd rather see this guy chewed up and destroyed than my own hand. So go ahead and put it whatever distance. Clamp this down. Make sure you're not on it. It takes a while for it to go down, and it makes a lot of dust if you can't notice. So the reason this guy sometimes is not the best thing in the world is if you're doing what the type of cut I was showing, this has to come off somehow. I'm not 100% sure how this comes off. So we're going to go ahead and raise them all the way up to cut this guy in half. So pretty much, it makes a really straight cut. It makes a fairly good cut. It'll do the job for weird cuts like this that you can't do on a bandsaw very well to keep it straight, or any other. And anything that's really, really thick like this, and you want a very long cut straight down, you can use this tool. There's no other tool here that will do it. You can do it on the bandsaw, but your line's going to look like a snake. This is going to keep it straight. This is probably the one tool, like if you ever have to use it, tell one of us, we'll show you how to use it again. Because we're never going to use this tool that much, but when we need it, we need it. And we'll show you how to use it again. We'll teach you how to push things through. But for the sake of this, it's a good idea for y'all to see it, hear it, kind of smell it, and see what you have, what you guys have to use to build a robot. After that, we have a scroll saw. Scroll saw, mostly used for very accurate cutting, like very accurate. Like, oh, I need to take off 1/4 of an inch from something. That's a little too much for this guy. I don't feel safe using that guy. Please don't use the other two guys. And again, don't use a drill press. I have seen people try to take off material like that with a drill press. This guy is actually not bad to use. You have a little guard so most material won't like spit up in your face. Your fingers can actually get somewhat close to the blade. I wouldn't recommend sticking your finger in the blade. It will still cut you, and I mean cut you. And you could do very nice curves with it. We can probably nice things with Lexan with it really easily. Like say we need a nice weird curve Lexan. You can probably do that on the scroll saw. This is a Dremel. I'm actually not kidding. This is actually a Dremel. Little Dremel pieces can go inside of here. And you have variable speed. It's normally better for like little drills, like so a little milling or sanding and stuff. So Dremel. We also have an actual Dremel outside. Safety glasses are actually a really big thing. I know it's a pain in the butt. I know I'm going to get on your nerves for saying put on your goddamn safety glasses. Just do it. It's easier. I know you can see better without them. I can see better without them, trust me. But what's worth more, seeing a little better while you're cutting or having a piece of aluminum going into your eye? Because the dust will get in your eye. It will make you blink a lot, tear up, and you're going to think, I can just push through this and cut, and you'll slip and something bad might happen. This little hole thing is for safety. Because that way you've all seen the tools, you all know what they are, you know how to clamp them, at least one per person. We don't have enough tools for everybody to use them. Once you have used the tool, I've seen somebody use the tool. If you don't feel comfortable using it, tell somebody, like a mentor or somebody, and they will use it for you. They'll cut you the piece and they'll give it to you.
Or we will show you how to use it. If you don't feel comfortable, we'll always be here, so we'll be able to show you how to use any of these tools.